Good day everyone, I am Rainier Hube El Batoktoy and we're about to discuss definite integrals. So first, we're going to find the antiderivative of x squared dx evaluated from -1 to 2. So we all know the basics on how to get the antiderivative of um, using the power rule, wherein uh, xn is equal to x n plus 1 raised to the power of n plus 1 over n plus 1. So as we have here, where we have x squared, so it will be x2 plus 1 over 2 plus 1 evaluated from -1 to 2. So we're going to have x cubed over 3 evaluated from -1 to 2. -1 to 2. And then we're just going to substitute the upper limit into this equation and the lower limit into this equation. So, and we're going to subtract the lower limit onto the upper limit. So it will be just going to be like this, equal to 2 raised to the power of 3 over 3 minus -1 raised to the power of 3 over 3. So just simplify. 2 raised to the power of 3 is equal to 8 over 3 minus -1 raised to the power of 3 is equal to -1 over 3. So 8 over 3 plus 1/3 is equal to 9 over 3, or 9 divided by 3 is equal to 3. So that's our answer into this equation. So we are finished into using the power rule. So we're about to proceed into the constant rule. So let's take for example antiderivative of 3dx evaluated from 1 to 5. So you know how to find the antiderivative of constant, wherein we're just, for example, we're just going to add x, because for example antiderivative of 5dx is equal to 5x, antiderivative of 5x raised to the power of 0, because any number raised to the power of 0 is equal to 1 dx. So if we are going to use the power rule, so we're just going to first we're 5x0 plus 1 over 0 plus 1. So 5x0 plus 1 over 0 plus 1. So we'll get 5x raised to the power of 1 over 1, which is also equal to 5x. So therefore our antiderivative of 3 dx here evaluated from 1 to 5 is equal to 3x evaluated from 1 to 5, and same as what we had to do on the last on our first equation. We're just going to substitute the lower limit and the upper limit, and we're going to subtract the lower limit into the upper limit. So it will be like this: 3 times 5 minus 3 times 1. So 3 times 5 is equal to 15. 3 times 1 is equal to 3. So we are going to have 15 minus 3 is equal to 12. So that's our answer. And we're going to proceed to definite integral of polynomials. So we are going to have the first example. Antiderivative of 3x squared plus 2x cubed minus x raised to the power of 4 dx evaluated from -1 to 2. So first we're just going to find the antiderivative of 3x squared plus 2x cubed minus 4x raised to the power minus x raised to the power of 4. So we're just going to apply all of the rules that we had a while ago. So 3x, so it will be 3x squared plus 1 over 2 plus 1 plus 2x cubed plus 1 over 3 plus 1 minus x 4 plus 1 over 4 plus 1 evaluated from -1. Oh, sorry. This should be +2. So we'll just need to simplify first. So 3x cubed over 3 plus 2x4 over 4 minus x5 over 5 evaluated. So again, so as we simplify it, so 3x cubed over 3, 2x3 plus 1, so 2x raised to the power of 4 over 4, and x4 plus 1 over 4 plus 1, so x5 over 5 evaluated from -1 to 2. So now we are about to substitute. So 3x times 2 cube over 3 plus 2. So here's our x. 2 raised to the power of 4 over 4 minus 2 raised to the power of 5 over 5. And then so here's our upper limit, and next is our lower limit. So minus -1 3 times -1 raised to the power of 3 over 3 plus 2 times -1 raised to the power of 4 over 4 minus -1 over 5 raised to the power of 5 over 5. So we're going to simplify it. So we can cancel this one. So we're just going to solve for 2 cubes, which is 8. So, and we also can cancel this one. So be going to 2. Then it can be 2 raised to the power of 1. So we can also cancel this 2 raised to the power of 4 divided by 2 raised to the power of 1. So it will be 4 minus 1. So 2 raised to the power of 3. So 2 raised to the power of 3 is equal to 8 also. Then here, so minus 2 raised to the power of 5 is equal to 32. So over 5 minus 3 times -1 raised to the power of 3. So -1 raised to the power of 3 is equal to -1. So 3 times -1. So we can cancel this one. So it will be negative 1 plus, so we can cancel this one, so it will be going to 2, so negative 1 raised to the power of 4 is equal to 1 over 2, so plus 1/2 minus negative 1 raised to the power of 5 is equal to negative 1 over 5, so equal to negative 1 over 5. So simplify again, so we can add this one, so it will be 16 minus 32 over 5, so distribute the subtraction sign, so minus negative 1 is equal to plus 1, so plus 1/2 minus 1/2 is equal to 1 negative 1/2, so this will be this will be addition, so if we distribute this one, it will be negative 1/5. So next, simplify again. I'm sorry. So 16 plus 1 is equal to 17, and 32 over 5 minus 1 over 5 is equal to also, I'm sorry, so this would be plus, minus 31, oh sorry, 31, it will be minus 33 over 5 minus 1/2. So in order to simplify this, we're going to find its least common denominator, or LCD. So its LCD is equal to 10, so 10 divided by 1, so this can be have over 1 here, so 10 divided by 1 times 17 is equal to 170, so minus 10 divided by 5 is equal to 2 times 33 is equal to 66. Then 10 divided by 2 is equal to 5 times 1, so it means 5. So to again simplify, 170 minus 71 is equal to 10. So 66 is 66 minus 66 plus negative 5 is equal to negative 71. So it will be 170 minus 71 equal to 99. Again, so 170 minus 71 is equal to 99, and copy the denominator, which is 10, and so the answer is 99 over 10, or 9 and 9 over 10. So I think that's all for definite integrals, and again, I am Rainier Ho Blacaba Batuktoy. Good day.